Hello. Good afternoon, everyone. Let me know if you can hear me. Send the pluses in the chat, please. And we would start in a few minutes. Today, we will briefly touch the task number 9. It was about the containerization. Actually, it was kind of part of the task number 8, where we just create the cart application. But now we would erase this one from the Lambda deployment. Actually, we would just destroy the deployment via Lambda, and we would try to deploy it with the Docker containers. Docker container, the Elastic Beanstalk application. Unfortunately, I still didn't manage to make this application work, so I would just try to show you the examples on how it works. But if you succeeded the previous one, and like I didn't, so I think you would not have any problems if you would understand the idea behind the Elastic Beanstalk and Docker itself. Okay, so since now our communication is up and running, I can see already the plus in the chat. So I think let's get started. So let me make it a bit more convenient for me. Okay, so let's put it in here. Okay, so here is the part of our presentation. So first of all, we are at the module number 9, which is almost the final one. We only have the backend for front end, but we will talk about it, I think, on Monday, I hope. So, and the module number 9 is forcing us to make our application work on the container. Wait a minute. Okay, I would wait. Sure. But while we're waiting, I'll try to maybe explain what we will talk about today. So first of all, we'll try to talk about the containerization itself. So how it works. How does it work? It's not regarding the AWS, but actually containers are, I think, the most popular way to deploy the application because you don't depend on the hardware or software installed on your PC or on your server inside clouds or your on-premise one. So you can just wrap your application inside the container and just run it everywhere you want. The result everywhere would be the same because the operating system and all the necessary files would be wrapped inside the container. Next, we would take a look on what Elastic Beanstalk is, how it works, and how can we communicate with it via the CLI and or via the AWS console. And I think at the end, if you would have any questions, I would try to answer them. So if you have any, you can mark them down or write them in the chat. We will try to. I will try to answer all of them. Okay, so I suppose let's get started, and we would start with the containers itself. So maybe it's not necessary for you to understand how they actually work, but still. So you can think about the Docker, about the containerization itself, as an application on your PC or on your server, whatever it is. You're just installing this application, and then whenever you're creating any kind of containers, you can just run them with this application. And you also should understand that you can run as many containers on your, for example, local PC as you have enough resources for them. So it may be 1, 10, or maybe even 1,000 of the containers. It all depends on the resources you have. And now I think we can just go ahead and take a look on what Docker file is and how can we wrap up in our application inside the Docker. So let me share my screen and I'll try to show you how it looks like from my end. So first of all, I try to wrap my application, even the one which is not working, in the Docker, and actually I'm almost succeed. So yeah, sometimes it just connects to the database, but nothing else. I don't know what's happening, but still. Um, I think it would be enough just to take a look at the Docker file. So the Docker file is kind of instruction for the Docker on what to do to create the image which we would use to run the containers. Um, it's kind of two different instances. So first of all, you have Docker as an application. Then you have images. So image, you can think about it, for example, if you want to install the Windows, or if you want to install the Ubuntu or any other operating system, you will always have an image, which is already containing all the necessary files to install it. And actually the same is in Docker. So you just write in this Docker file and explaining, okay, let's take a look at the second string in this case. So it's just saying from node 18 Alpine as builder. Um, in this particular string, we are telling the Docker to go to the internet, to the official Docker registry, take the container which is named node 18-Alpine. Alpine is kind of the name of the operating system. So you may have Ubuntu or anything else, but in case of Alpine, it's just have the minimum necessary tools to run your operating system. So it's usually just the smallest one. So if you are if you want to create the smallest possible image, consider using Alpine images because usually there's the smallest one. And as builder is telling the Docker container to use this layer, let's say, as a variable. And you may take a look. So at the string number 17, we would try to export from this one all the necessary files. So let's go ahead to the line number 4. We are just saying to the Docker image, but we would work at the user /crc/app directory. So whenever our Docker container would start, it would first of all go to this folder, and all the next commands would be ran in this directory. Next, we are just copying everything from our local machine. In this case, it would copy all of the source files. Okay, no, in this case, it's just package.json. Yeah, it's just package.json. It would copy the package.json file inside my machine, inside the Docker image. Then it would install all the necessary dependencies. And at the 10th string, we would just copy all the source files, all the files which is located right near the Docker file. We would copy them inside in our image. And then we would build in our application. We would run npm run build, which would run the nest build, if I remember it correctly. And that's it. So now let's imagine that we already have this container up and running. So we would have the container with some kind of operating system, which is Alpine in this case, pre-installed Node version 18, and our application would be already built. So at this point, we are already free just to run in our application with Node space main.js, and it would be enough. But since we don't need all of these source files inside in our container, we are saying, so, okay, once again, let's take the same image, Alpine with the Node 18, set the same word dir. So it would be absolutely new container. and this time. But in the cache, somewhere in the random access memory, maybe, so in our Docker would still have all the information, all the data, which is located in the previous layer, in the previous stage. So in this one, which we uh, created in here. And then we are saying that from this previous container, where we are just built in our application, copy all that is contained in the /dist folder to our new freshly created container. In this case, in our new container would have only the data from the /dist folder and nothing else. So all of the source file will be, I would say, not removed, but would be not added to our new one. And with this statement, we are just saying to expose the port number 4000 to the outside. So since our application is listening on the port 4000, we are just saying, so okay, here we go. Let's make it port accessible and listenable from outside, because otherwise your container would just live inside of its own and don't have any exposed ports. So you don't have any options to access it. I mean, access the application itself, but you would still have an option to go and log into your container. And the next string just saying, so, okay, since we are done with the files, and now we have only all of the necessary files, just run node and this main.js. So in our application, in this case, would be ran, and our container would live. One more important thing about the containers. So containers are only living when they are doing something. So this command, cmd, just saying to run in our application. And since in our application is a web application, it always listening on the port. So it's just enough to make this container up and running until we don't kill it, or until something bad happened inside it and it would just crash. But if you don't mention any command inside of this one, so if, for example, you would just leave cmd, let's say ls-la to show everything would contain inside in our working repository, and our container will just start. We'll just run this command, give us an output of this command, and that's it. When it would just die. Now maybe let's take a look on how it works. Unfortunately, in my case, I just for security policies or commercial policies, I can install the Docker inside on my working laptop. So I just use the Podman, which is actually the open source Docker, let's say. So it's just doing absolutely the same, but just called in a different manner. And with this one, let's say Docker. Oh, actually, I think I have all these comments already in history. So let's say just Podman build. And in this case, I would say that first of all, I would say Podman build. You can think about it as Docker build -t to create the name of this image. And then I'm saying that to make the Podman or Docker understand that I would like to build from this repository. And since I have the Docker file in here, Podman will automatically locate it. But if you have the Docker file named somehow else, so Podman or Docker underscore file, for example, it would say that you don't have Docker file inside this repository, inside this folder, and you should specify it. But now I think let's go ahead and try to build this one. Quite fast. Okay. So now what can I do? Since I changed the node this main.js to the ls-la, I would be provided with all of the data I would be provided with the output of this command once I try to run run the container with this image. So let's try to do this. I need to specify the name of the image I'm using. So in this case, it would be card up. And let's also add rm just to remove the container once it will crash or die. Okay, I think it should be enough. Fair enough. Let's do it like this. Bin slash sh. Yeah, I think it would be enough. Now let's try to build it once again. Bin slash not found. Okay, I suppose we can just then. Okay, yeah, maybe the problem is in here. Yep. Sausage file directory. Can't open ls la. Okay, let's try to do it like this. Otherwise, we would just try to run in our default image, and we would try to not log in, but try to run in the interactive mode, which is makes it able to run the container and go just inside in our freshly created container. Okay, since we've built, we can just run. Okay, doesn't work, unfortunately. Let's do it like this. Let me remove this one. Now let me build it once again, and then I think, well, so many of them. Oh, let's just Podman run. Somewhere here I had, yeah, I think this one would be enough just to run this container, expose the port. So in this case, this command is saying that I want to run the container with this particular image, card app. Actually, it's the one we've just built. Now I'm specifying the name of a container just to make it a bit more convenient and possible to remove it at the end. And I'm saying that I want to expose the port 4000 of my local PC, not expose, but forward all of the requests to my local port number 4000 to the port number 4000 of the container. And then I'm specifying rm just to remove this container when it's finished its job, and it to run the interactive mode. So now the container would not be just run, but I would be right inside of this container. Yeah, as you can see, user src app. So this is exactly the working directory of our image. And if we try to run ls-la inside of this one, we would see actually pretty similar folder structure, which I have on my local PC. So what does it mean? Actually, we just the Docker building this image, it just step by step made all of these instructions. It just built the application and exports the port, and that's it. Now, I think we may uncomment this one and try to build it once again. But let's say it would be, let's give it another name. Let's call it small, because we would extract only the necessary data from the first stage, and only this data would be used inside in our new stage. So, and this would make in our, we would take a look at the size of our images at the end. So now it's built, and now I think we can just name it small in this case, and we will take not the card app image, but card app small. We'll write it in the same way, and in this case, we would see, but inside in our container, we have only the data which is stored inside the, yeah, it's just, okay. So we have only the data which have been located inside the dist directory of our previous image. Maybe I can just open another one, and let's say Podman run. Let's open the previous one once again, since we still have an image. Okay, fair enough. Since the port 4000 is already used on my PC, I have to change it for another one. Now let's take a look at what's located in the dist folder. Yeah, here we go. So now, as you can see, it's pretty the same. So by using staging, we can avoid making our image much bigger than it should. Let's try to take a look at the images I already have to take a look at it. To take a look at this, I may just run Podman image ls, I guess. Yep, here we go. So plenty of images, but we should take a look at two of these. There is cart app, which was built at the first, which doesn't contain the second stage, which is only consists of all of the data, including the source one. And when we made it with the second stage, it shrinked in 3 times or something like this. Yeah, it's almost 4 actually. So what is the point on all of this? First of all, to waste the space on your machine, because sometimes you are paying just for every megabyte on your disk, even if it's cheap. But imagine you may have plenty of the images, plenty of the Dockers, plenty of the versions of these images. Because Docker also supports the versioning of the containers. So you may have the different tags on these. You may see it in here. So there is a cart app with the tag latest, but we also may have the tag, for example, with some special version. And actually, it's pretty useful because from version to version of your application, it may or may not support any commands or any functionality. So sometimes, even if the Docker registry doesn't explicitly save all of these images one by one, actually, it's saving just it by layers. And by a layer, I mean all of these commands. So when we've been building this application, you may see that the output of the build command is containing all of these steps. Under the step, you can understand the steps like the layers of your image. So Docker just saving this layer, and if it doesn't change from the previous build, it just stays intact. So it just saved on your local PC, for example, and you may use it or even reuse it at another image or another Docker file. And layer by layer, you are creating your image from which you later can create the container or can run the container. So I think that's it. What I wanted to explain about the Docker. But since my application doesn't work, I already created the small application, which I named the test app. Let's take a look on what's inside in here. So actually, nope. Yeah, like this. So it's just a web application which is also listening at the port number 14 or 4000, and it's just saying hello world once we are reaching this port or on this particular address. So in my case, it would be just localhost. And with this one, what can I do? So first of all, since I also have the Docker file in here, I can say just podman build. Podman build, create the name, so it would be test app, and build everything but located inside in here. Now when I go ahead and take a look at the podman image ls, image ls. Somewhere in here should be the test app. Yeah, 30 seconds ago. What can I do now? I can just run this application. I can just run the container with this image. To do so, I would use the command I used not long ago. It would be podman run. But I would change the port since first two of them already be used by number applications. I would say let it be 4002. Name for this application would be test application, and I would use the test app image. I don't need the interactive mode, so I would just remove it. And I would like to remove this container once it's stopped. Okay, I think it should be enough. Okay, so since the server is ready, we can just go ahead to the browser, try to run the local host on the port 4002. Yeah, here we go. So this is the web application which is running right now inside our application, inside our Docker container, just working. So it's just the web server working inside in our container. Okay, so right now I think that's it about from the perspective of the containers. Any questions? Go ahead. Otherwise, we would go ahead to the explanation or to the talking about the Elastic Beanstalk. So what Elastic Beanstalk is? Actually, it's just kind of framework. The framework which makes it a bit easier for you to deploy the application. And even from the first side, it may look quite complicated to run something, but actually, it would be a bit more complicated to do it by creating the application by your own inside with the AWS console, or let's say from any scripts or any infrastructure as a code tools like Terraform or CloudFormation. So as I said, but it's just a framework. What it actually do? I think we can just go ahead to the AWS console. Let me stop this one. Oh yeah, for some reason it just doesn't work like this. So I should just go and kill all of this. So there is an option to take a look at what's happening on your local Docker. And as you can see, there is one application is up and running, which is test app. And in order to kill it, I need just to say stop, first of all, stop the test app. And then we would take a look at what's running. What else is running? Yep. Docker PS, but now specifying the -a. Okay, yeah. Since we specified the -rm, they then instantly delete it once they finish their job. So as you can see, no containers inside of my Docker. Okay. Now, I think we can just go ahead to the. Let's take a look at the task itself. So what is it saying, and what should we do here? So with this one, first of all, we should install the Docker. So if it's not your enterprise computer, it's not provided from your company to you, or if you have actually, the Docker have some policies about this one. Yeah, if you have less than 250 employees, so you are free to use it without any licenses. But if you have more, So you should consider to buy the license from the Docker to install it and run it. Otherwise, I'd encourage you to run the podman, which is actually pretty the same. Once you succeed with installation of a Docker or Podman, anything would fit. So it's just for the testing purposes. You should install the Elastic Beanstalk CLI, which is maybe a bit challenging because if you have already installed the Python version above the 20 or higher, you would need to somehow install one more Python with the version less than 12 alongside with this one, or just run it inside the virtual environment, because Elastic Beanstalk CLI doesn't support the versions higher than Python 3.11. Keep it in mind. So, and now actually just to install this one, we should just go to the repository, just clone this one, and run the script, which is located in here. Actually, it will do all this stuff, all the necessary stuff. And the desired result is you would be able to run the EB command from your terminal. If you have any difficulties, feel free and say it in the Discord chat. I would try to help you if you are running it on Python. But otherwise, just before running the before installing the Elastic Beanstalk CLI, you should install the Python, the version less than 12. Python 11 is enough. 12 is too high. It would not work. Okay, so once we've installed the EB CLI, actually it's just, once again, it's just a wrapper above the framework, above the AWS resources. So it would just help us to deploy often our resources with the CLI, but not clicking the buttons inside in our AWS console. So, and if we have everything is up and running, so it would be as simple as my projects, okay, should be like this and like this. Yeah, here we go. And as I remember, it would be as easy as EB init, I think. Application test has been created. And once we are done with this one, it would be like, okay, let's take a look at the help. EB deploy, I suppose. EB deploy. We're forced to use single to not make the Elastic Beanstalk run the load balancer for us, because load balancer is out of the free tier, so it's better to use the single option in this case. What else? As I remember, we should also provide with the name of our application. Let's take a look in here. Oh, it's just EB create with CNAME and single. Okay, let's go ahead and do it like this. With single and also dash CNAME. Let's say my test application. Nope. Why not? Maybe it's expected a bit. Maybe it's expected after this one. Okay, looks like it is. So first of all, we've been prompted to specify the name of the environment, but we also provided with the default one. Next, would we like to run in our application of the spot fleet instances? What does it mean? As I said at one of the first lectures, AWS gives us an option to run the spot instances. Actually, it's just an instances which sometimes cheaper than the original ones in 90%. So you would just pay only 10% of the real price of this instance. But the downside of this approach, but these instances may be taken from you in any time. So AWS would inform you for maybe 10 or 15 minutes or something like this. Actually, I don't remember the exact time frame, but still, it's quite short. And in these 10 minutes, you would need to somehow um, redeploy your application from this instance, or maybe just create the backup of this instance if it's necessary. And after this 10 minutes, after the notification, and whatever this 10 minutes passed, this application would be just destroyed for you. It would be not yours anymore, and you would not restore any data from this instance somehow. So why did it useful sometimes? Because if you have such a stateful applications like the card API, in our case, we don't store any information inside of this application. All the data is stored inside in our database, and this application is just a proxy for our users to go and create this card. I think the worst thing that may happen is if somehow when our server would lost this synchronization with the database, the card of the particular user would be lost. But maybe it's not crucial. If we are talking about money, actually it's your choice. So would you rather pay more or just have the more stable application? But if you somehow would manage how to redeploy this connection in this case, yeah, because we are talking about the socket connections when we are talking about the web applications. And if you would manage somehow how to move this socket from one container to another, it would be cool because you would still pay less, but have an option to save these connections and save the cards of a particular users. So right now, I would say I would choose no, because even if you have the free tier account, you would pay for spot instances. Okay, what next? We would be prompted. Actually, nothing. So what would happen now? We would actually take a look at it at the AWS console when we would try to run to reach the same result with deploying the application, but with the AWS console. So it would be maybe more convenient and more informative for you. But right now, I will try to explain. So in our Elastic Beanstalk CLI, trying to talk with the AWS and create all of the necessary resources for us. And not just create the resources, but it would also, as you already, yeah, maybe not the most obvious part of this one, but now, right now, Elastic Beanstalk CLI just taking all of the data which is located inside in my working directory. Once it's finished, or maybe right now, maybe we can just go ahead to the my projects, school, and test app. Yep. So right now, Elastic Beanstalk CLI just taking all of this data and storing it inside my S3 bucket. We may take a look at it with the AWS console. Here we go, S3 bucket. It should be something like Elastic Beanstalk. And test application. Yeah, I already uploaded two of them, but here we go. It's 1939. Yeah, there is the archive of all of everything what is located inside of my working directory right now. Once it's done, Elastic Beanstalk going to the AWS and trying to create the EC2 instance for me. So EC2 instance is just a virtual machine which would serve as the machine with the Docker pre-installed on it. Actually, I've missed this step of the initialization, yeah, actually I've done it. But the problem is, since this repository has been already initialized, let's create the new repository. Here, let's go to this one and try to run sp. Oh, it's ep init. And if you can see, if we are first time running eb init in our directory, now we will be prompted to run first specify the region we would like to deploy in our application. In my case, it would be number 5, which is Frankfurt, EU Central 1. And the name of my application, let's call it new app. Not valid choice, but why? Okay, create new application or use the existing one. Let's say create the new application. Okay, in this case, temp dir. Okay, it's enough. And then, any questions? No. And then we are prompted to select the platform which which in our application would run. Since in my case it's a Docker container, but not any other programming language. Yes, you may say, but okay, but we are using the Node.js. Yes, we can maybe not wrap in our application inside the Docker image, but we may just say what in our application would be ran on Node.js. And it would be enough not to create the Docker file, but just provide all of the data without the Docker file inside in our S3 bucket or inside in our Elastic Beanstalk. But in my case, since it's Docker, I'm choosing option number 3. And now I need to choose from 4 options. So third and fourth one actually is just the old type of instances of the Amazon Linux. And first 2 is just fresh Amazon Linux. And we only have the difference if we are choosing the Docker or ECS. ECS stands for Elastic Container Service, which is kind of just Docker registry provided by AWS. So in this case, we should, in our image would be stored inside of this registry and would be ran from the AWS container registry. But in my case, it's enough just to choose option number 1 because I have a Docker file and all the necessary source to run my application. Do you need a separate SSH for your instance? Since Elastic Beanstalk would create the instance for us, it's possible to say yes. And in this case, I would be prompted to choose the key pair, which I already created for AWS. And with this data would be this key. If I provide in this key inside my instance, it would be enough just to run SSH and connect via the SSH to my instance, which Elastic Beanstalk created for me. Now let's take a look what's happening. Okay, now it's saying that my application successfully ran. Let's take a look at the Elastic Beanstalk. Here we go. And inside our application, we have a bunch of environments. So now we created just one, but we are free to create more of this environments. And it makes sense when we have, for example, development QA or production environments, and we would like first to try something new on the dev environment, and we can deploy it on the dev environment. Then another environment, but the production environment would be still running on the in our previous source files. So where is the domain? And if I click on it, I should see the same hello world which I saw when I've been running this container on my local machine. So that's actually mean that right now the Elastic Beanstalk just first of all created the autoscaling group for me. Okay, maybe let's go with another order of this one. So yeah, actually, um, at this step, it would be enough for you to be done with the task number 9, because once your application is deployed, yeah, the only thing you may need to change the API paths as usual to the one provided with the Elastic Beanstalk. So in this case, it's just what is located under the domain. And once you are done, redeploy your front end part, and then it would be enough to make sure that everything is up and running. But now, let's maybe take a look on what options do we actually have when if we are choosing to create in our new application. Um, let's say new application. We would just briefly take a look on what's happening and what an options do we have when we are deploying this one. I'll create the environment. It would be web server. This name is enough. I will be provided with the randomly created domain, but if you want, you can choose your own. Managed platform. I don't have another option because actually you're free to choose to create any custom platform. So if you can see, there is no options like Rust, for example, or any other programming languages, but you're free to create the image with this one and then use your custom platform. So which is actually cool, and also maybe use not only inside the Elastic Beanstalk, but also inside your Lambda functions, since you are so. Um, okay, where is the question? Yeah, Evgeny, thank you so much. But actually, correct me if I'm wrong, but there is an option for the Elastic Beanstalk. So if we just try to choose no verify SSL, I'm not sure what it actually does, but if it may help. But otherwise, yes, actually, Evgeny is right, because I saw in the chat the approach was proposed to create the API gateway in front of our um, Elastic Beanstalk deployment. So it would be an API gateway which is responsible to create the connection inside of our internal application, which is located inside the Docker, which is located inside the EC2 instance, which is managed by auto-scaling group inside in our AWS account. But yeah, thank you so much for this information. Still, if you would face such an issue, feel free to ask for help inside in our Discord chat, or just search for this information, because as I said, the solution already been proposed. So, okay, we've choose the managed platform. Now we choose Docker, as I shown you when I've been running EB init for the first time. Choosing this same image, choosing the platform version. And now I need to provide the code. In my case, I already uploaded the code to the S3 bucket. So I can just go to my S3 bucket. Where is it? Yeah, here we go. So latest one should be this one. And if I just copy this URL, since this S3 bucket is publicly available, it would be enough for Elastic Beanstalk to take all of the necessary data of this application for running this application inside of my Docker image, Docker container. For presets, I think it's one of the most interesting part. I would just choose a single instance because it's free tier, but in my case, it's just to take less money. The second option is, as I said, it's about the spot instances. So my application would try to run on the spot instances if they are available in the purpose of the cost savings. In case of a high availability, the Elastic Beanstalk would not just create the instance, but it would also create the load balancer for me. And what is the most interesting part about this one, in case you have the load balancer in front of your application, um, maybe let's try to draw a bit. Um, yeah, it should be like Scratch.io, something like this. Okay, so let's just say draw. Yeah, I will just try to find it. Yeah, I've been using this one. Okay. Yeah, pretty interesting how to remove this one. Anyway, we can just layers. How to erase all of this? Okay, nothing helps. Okay, now let's try to imagine what we have a user which tried to connect to another application. And in this case, if I would just run one instance, even if it be inside the auto-scaling group, so which means that AWS would take care to run new instances if something is happening with the previous one. All of the data would be routed right to my application. So it would be like IP address of my application, 17, 20, 30. It would be just the PO of my application, and all of the users would be accessing my application with this IP address. So, and imagine if we have not only one user, but thousands of users. Actually, my small EC2 instance would freeze and possibly die. And what did AWS provided for us? They provided us with the load balancer. What does it mean? In this case, all of the users would first reach the load balancer with each personal IP address. So let it be 68, 17, and 130. It would be just port 18. And under this load balancer would be an auto-scaling group. Actually, it may be not one auto-scaling group, but it may be, yeah, usually it's just one auto-scaling group. So maybe not in this way, but okay. So under these load balancers would be the auto-scaling group, let's say auto-scaling group, which is responsible to create new instances in case the previous one is overloaded. Under overloaded, you may understand actually almost everything you may take from your instance. Because once you install in this special agent, which is providing the logs to your CloudWatch from the EC2 instance, you may take almost any data you want from your instance. So if you are lack of CPU or RAM, let's say, auto-scaling group would take a look at it and create the new instances for you. And all of these instances would be automatically added to the load balancer. So now, once we are reaching the load balancer, we would be routed to another instance on which our application is running. And this load balancer would be responsible to make sure that all of the instances and all of the parts of an application have pretty the same load. And actually, we are responsible to create the metric which would be used to scale or descale, I don't know how to say properly, the auto-scaling group. So imagine today you have one user, but tomorrow it's 1,000 of users. And you may say, okay, if I have more than 500 of requests for any instance, please create another instance. Now it will be created. And for example, if you specified on the load balancer the round robin approach to distribute the requests. So in this case, not all of the requests would be landed on the instance number one. Because now, since the autoscaling group created another one, now we have the second instance. And in our data, since it's round robin approach, first request would be landed on the first instance, second on the second, third on the first once again, and so on. And now we may say to in our autoscaling group, okay, you may scale the instances as many as you want, but not more than 3, for example, just in the just to avoid, for example, the DDoS attacks or something like this. So if it's not the healthy traffic, let's say, we would be secure from this one. If we would somehow limit the amount of limits autoscaling group can create. And then when, let's say, it's night, and there is again 1 or maybe 2 users, you may say to the autoscaling group, okay, once we have less than 200 requests to our instances, just scale the machines down. Let's just run one necessary machine, which is quite sufficient, quite enough for us to make our application up and healthy running for all of our users. So this is what we are choosing in here. But as I said, in my case, I would just run the single instance because I'm already a lack of free tier account. So, and for the test purposes, it would be enough for me. Once we are done, actually, it was the most interesting configurations. Here we are supposed to create the necessary access for our Elastic Beanstalk to the S3 bucket for our EC2 instance, but feel free to leave it as it is. Only you can just maybe specify the key to have an option to SSH to your machine. Now click next. Choosing my default VPC, default availability zone, and here you may see the database options. So in order to make your application more to communicate with your database in more convenient and in more secure way, you may specify all of the necessary environment variables inside of this part. Actually, you can do the same with the EB CLI, providing the set-env option, if I remember it correctly, and then specifying all of the environment variables inside of this one. But you also have such an option inside the AWS console. I'm clicking next. Now I'm choosing the disk size for my instance, but I would say intact, monitoring, okay, deactivate MST. Now I'm also forced to choose the security group for my instance. So it's not about the policies for to communicate with the autoscaling group and my let's say Elastic Beanstalk and instances. It's about the network security. Capacity, yeah. In this case, once again, I'm prompted to create the load balancing. But right now, I would leave it the single instance because load balancer anyway costs some money. But we will try to take a look at how it looks like. Let's leave everything else intact. So the size of instances and the image these instances would run. Now, health proportion. Let it be basic, just to avoid spendings. Rolling updates. I can't say much about the rolling updates, but I guess it's something about the. So since Elastic Beanstalk is quite the managed service, once again, we are not responsible to update in our EC2 instance. Now, EC2 instance is a head edge of the AWS in this case. So all of the security patches and so on, the AWS is responsible for this one. Perform software. No, next. I think it's the last one, invalid option. Why though? Let's take a look. What I missed. Activated. Let's remove this one. How does it work? Yeah, I think that's it. Okay, so here's a quick summary, quick review on when I just clicked. And once I click the deploy, what would happen? So let's close this one and let's go ahead to the auto-scaling group. Now the auto-scaling group would be created for me. So under the auto-scaling group, I mean the group of the instances, which is enough to run my application. And since we specified the image, so in this case, we don't have any kind of policies. We only have the desired capacity, minimum and maximum, minimum and maximum capacity of the instances, which is auto-scaling group may run. But if in our application would grow, we may specify, for example, not maximum, not one, but two or maybe three instances or whatever you have. And now, yeah, but unfortunately, I don't have any metrics right now from my instances. But let's try to take a look on what's happening here. We may say, yeah, in this case, it may be just CPU utilization. So if in our instance would go above the 15% of the CPU utilization, in our auto-scaling group, okay, there's the another one created, which is for an our application. So once my EC2 instance would have more than 50% of the average CPU load, in our application, in our EC2 instance would be created from the AWS side and provided with all of the same application. So it would run all the same Docker in this case. And our application would be accessible in any case. But since it don't have the load balancer, it would not make it possible, let's say, to count maybe the requests for an our instance, but we would only operate on the metrics of an our instances. So now I think let's have a look where it happened. Yeah, now since our application is successfully deployed by hand, we can see pretty the same result. So it's just saying hello world and nothing else. And to take a look on where in our EC2 instances is running, we can go to the EC2 instances. And here we can see two instances. One is where is my RDS running for the test purposes. The second one is for the test application, which we deployed with the EB CLI. And the next one is for the new application, ENV, which is we've created with the AWS console. Actually, I think that's it from the perspective of the Elastic Beanstalk and with the module 9 itself. I'm sorry I took too much time from you. Yeah, it's already 1 hour we are running. So yeah, I think the main idea you should take from this one is on how Docker works and why did it quite most, I'd say, convenient and most popular technology nowadays, and what Elastic Beanstalk is. To be honest, I don't have the production experience with the Elastic Beanstalk. I just had some experience, like for myself, on some workshops and labs. But yeah, from my knowledge, this is it. So this is how it can help us to deploy the application in, let's say, more convenient way when just clicking all of these resources one by one. And also, yeah, keep in mind that it's managed resource, so the security patches and the operating system duty is not in our head age anymore. So it would lie on the shoulders of AWS. Um, okay, where is the question? When do we start with database? Do we have to use the previous one? It's public. Um, Here is the thing. Actually, we should use the database created for us previously. But now, since and our application is running inside the EC2 instance, actually pretty the same as the in our RDS, we may get rid of this IP address and just run it inside in our VPC. So without any public access, it would be quite enough for in our application to go to your database and take everything it needs. Because if we are operating on the same subnet, the connectivity would be pretty sufficient to run them inside of this just local VPC without any external access. I hope I answered your question. Okay. If you don't have any questions, I think let's call it a day. So the task number 9, I think in comparison with the task number 8, is much more easier. The only thing, yeah, you may face is SSL. But I would take a look on what can I do with the setup I already have with partly working application. Okay, I would try to find the solution and I would try to provide you with the most convenient way to avoid it. But I think, yeah, actually the approach provided with in the Discord chat is quite convenient. I'm not sure it's the best practice. But I don't have much experience with web applications, actually. Okay, I will take a look. Okay, so thank you so much. Thank you for your patience. I wish you good luck with this task, and I hope it would not take much from you. I think next time we would meet on the next Monday, and it would be in our last meeting. I would take a look at the task number 10. As I saw, there is nothing special, but it's like you should just create your one more web application which is responsible to take the request from the CloudFront and provide them inside in our already created environment. So like Elastic Beanstalk with the cart API and in our product services. But yeah, I will take a look and I'll go back to you on Monday. Okay, so thank you for your patience. Thank you for your questions. Have a good rest of the day and see you on the next Monday. If you have any questions, yeah, feel free. Don't hesitate to ask them in the chat. I will try to help, or your fellow colleagues would help you as well. Okay, see you in a few days. Bye.